Hi viewers, welcome to this integral. Integrate from 0 to 1 x e to the power of x dx. Okay, so I'm going to use what we call integration by parts here to integrate this integral, and it's very easy. Okay, so under my solution tab, I'm going to consider um, the following. Hope you're following. I'm going to let my u to be equal to x. So this part here, and this to be my dv equals to ex dx. If you're aware about the integrals, then it should be clear that I want to determine the derivative of u with respect to x, and that gives me 1. And then here I'm going to integrate both sides, and by so doing I'm going to get the integral of e to the power of x, and that gives me e to the power of x. I'm not going to change the limits of integration because eventually I'm going to come back to my real function, okay, my real integral. So from there, I've said that I'm going to integrate by parts. So this one reduces to uv, so my u is x and my v is e to the x, so minus the integral of now du dx times v, so my du dx is 1 uh, times e to the x, which is my v, then dx. Okay, so this gives me x e to the x. When you multiply 1 times e to the x, it remains the same, and you integrate, that gives you e to the x. Okay, so I'm not going to put a constant of integration because it is a definite integral. So I'm going to place my limits here. So when I substitute 1 in the entire expression, I'm going to have 1 times e to the 1 minus e to the power of 1. And then when I subtract, when substituting 0, I will have 0 times e to the 0 minus e to the 0. And this now becomes 1 times e to the 1, that's e to the 1 minus e to the 1. And then 0 times e to the 0, that's 0 minus e to the power of 0. So I'm almost done here. We have e to the 1 minus e to the 1, that's 0 minus 0 minus e to the 1, that's e to the 0, it's e to the power of 0. And this gives me plus here now. So we have e to the power of 0, which is 1. And that is quite easily done. Thank you.